Good afternoon or good morning, whenever you're watching this. For the homework from yesterday, homework from Tuesday, it was page 394, 3, 5, 9, 10, 13, and 15. All right, take a look at what you have, and here are the answers. Now, I have them all worked out on this next slide, so you can go through and see what I did. Now, that doesn't mean you did it exactly the same as I did, but you still need to get the same answer. So as you see in this first one, what I did was I took, since y was by itself, I took the x plus y, put it in where that y was, and then solved the equation. And once you get an answer for the first variable, you substitute it into the other equation and get your second variable. And so all the 6 problems are highlighted here. And you may, like I said, you may or may not have done them exactly the same, but you have to get the same answer. Now, this is what we call substitution. When you take two equations and you substitute one equation for the other. And this is part of solving for a system, which is what our quiz is going to be over on Thursday. So we just really need to review a couple things just to make sure. All right, now there was guided notes. Hopefully you printed those out, or you need to go print them out, or at least copy these down on another sheet of paper and put them in your notebook. But we're just going to review solving systems by graphing and by substitution. First, let's kind of continue on the substitution path. Take a look at this first problem. Video Club A charges $10 for membership and a $3 per movie rental. So it's a $10 upfront fee and then $3 per movie. Video Club B charges $15 upfront for the membership and $2 per movie. For how many movie rentals will the cost be the same at both video clubs? What is that cost? All right, so we want the cost to be the same. And so we got Club A, we want the price for Club A to equal the price for Club B. For Club A, it's $10 plus $3. So the cost is going to be $10 plus $3 per movie. I'm just going to use M for movie. And for Club B, the cost is going to be $15 up front plus $2 per movie. So depending on how you do this, you could either set them directly equal to each other, or you could have done a systems of equations where we do C equals 10 plus 3m and C equals 15 plus m. But what you do is, since I got C by itself, I'm going to substitute that 10 plus 3m in for this C, and then set it equal to 15 plus 2m. And all I need to do is solve for the number of movies, which is m, by subtracting 2m. Ten plus m equals 15. Subtract 10. I get m equals 5. It says, for how many movie rentals will the cost be the same? Well, that is for 5 movies. So the cost will be the same for 5 movies. What will that cost be? This is when you plug it. You can plug it into either equation, and it's better give us the same answer. So you got C equals 10 plus 3m, and you get C equals 15 plus 2m. Well, m equals 5. So what's 10 plus 3 times 5? 3 times 5 is 15. 15 plus 10 is 25. Well, here it's 15 plus 2 times 5. Well, 2 times 5 is 10, and 15 plus 10 is $25. So it doesn't matter which one you plug it into, the cost is going to equal $25 for 5 movies. That's the only time it's going to be the same for 5 movies. For anything less than 5 movies, A is going to be cheaper. For anything more than 5 movies, B will be cheaper. So you need to be able to set up an equation, a word problem into an equation, system of equations. All right, now solve the following system by substitution. 2x plus y equals negative 5, and 3x minus y equals 7. You want to figure out which variable is going to be the easiest to isolate. And we talked about yesterday is if it has no coefficient in front, and this y or this y doesn't, but I would always choose the one that's positive. Okay, because if it's a negative in front of there, you're going to have to divide by a -1. And that can get a little messy. So I'm going to subtract 2x, and now that gives me y equals negative 2x minus 5. So now this will go in for this y. All right, here's where you got to be careful with this minus sign in front of here. It's going to be 3x minus whatever y is. You need to put the negative 2x minus 5 in parentheses, okay, to make sure we get this right. And when you do that, you remember there is a 1 in front of that negative, and you really need to distribute a -1 inside the parentheses. So this becomes 3x, -1 times -2 is plus 2x. -1 times -5 is plus 5 equals 7. 3x plus 2x is 5x. Whoops, I don't want to, yep, 5x plus 5 equals 7. Subtract 5, and then I get 5x equals 2. All right, so now I got a case when I divide by 5, I don't get a whole number. I get 0.4. So you can keep that. Now, since 0.4 is a terminating decimal, we can use that decimal. If it was like a repeating decimal, we'd have to use a fraction. So to get my other answer, I take in 0.4 and plug it in for this x. -2 times 0.4 gives me -0.8 minus 5, and -0.8 minus 5 is going to give me -5.8. So this is one of those cases where we do not get a nice answer in terms of whole numbers. That's okay. That's going to be the only point where these are both equal. That's the only point that works for both of them. So you plug in 0.4 and then -5.8 for y. So every now and then you're going to get decimal answers. That's okay. Now this one here, like I said, I like to write these beside each other. I said we always want to get the variable by itself that does not have a coefficient. Well, if you look, this is a 4, a 2, a 2, and a 4. You do not have a variable that does not have a coefficient in front of it. What I would see now, but you got to solve for one of them. Easiest thing to do is you want to see which variable or which coefficient will go into the other constants. So like this 4 will not divide into 2 or the 26. That lets me know that would give me a fraction if I would solve for x. This 2, however, will divide into 4 and 26. So if you got a number that will divide into both of the other numbers, I would solve for that. So that means I am going to solve for this variable. I'm going to solve for the y. Well, to do that, I need to subtract 4x. I get 2y equals -4x plus 26. Now look what happens when I divide by the 2, because this is what I was trying to look ahead. And now 2 goes into -4. It gives me -2x. 26 divided by 2 is positive 13. So I get nice whole numbers. You could solve for any of these variables, but you could also get fractions, which would just make the work harder to do. If I can get constants, I'm going to try and do that. So now take this value, -2x plus 13, because it's the same as y, it's equivalent to y. And I'm going to substitute it in for y. So I take that y out, make sure I use parentheses. I replace it with negative 2x plus 13 equals 22. Distribute the 4, and when I do that, 4 times negative 2 is minus 8x. 4 times 13 is plus 52 equals 22. 2x minus 6x, negative 6x, plus 52 equals 22. Subtract 52, and I get negative 6x equals 22 minus 52, which is negative 30. Divide by negative 6, and I get 5 for my x value. All right, we'll go back over here where you got the y by itself. You get negative 2x plus 13. Replace the x with 5. Negative 2 times 5 is negative 10 plus 13. And negative 10 plus 13 is 3. So in the end, my final answer would be 5, 3. It's the only point, the only set of ordered pairs that will work for both of those. Okay, so the first one, just want to make sure you are able to isolate a variable. And if you have a minus sign in front of the parentheses, you have to distribute a negative 1. And then what do you do if they all have a coefficient in front? You try to find a number that will go into both, which constant will go into both other terms. It'll make it the easiest. So we pick this 2 up here. All right, hey, let's hit back over section 6.1. Solving by graphing and also testing whether ordered pair is a solution. So if you, and this is kind of set up nice for you. So the point 3,1, is it a solution? Well, we just plug it in. So x is 3, y is 1, and now we're just going to kind of work our way down. 3 plus 3 is 6, and then on this other side, does it equal 6? Yes. All right, how about 4x minus 5y? 4 times 3 minus 5 times 1. 4 times 3 is 12. 12 minus 5 is 7. Okay, and that's what we want on the other side. So yes, this is a solution. All right, how about 6 and negative 2? 3 times 6 minus 2 times negative 2. Well, 3 times 6 is 18. Negative 2 times negative 2 is a positive 4. And that gives me 22. All right, so now it doesn't work for that one. Technically, I know it's not a solution, but I'm always going to want you to do both of them. So I still want you to see if it's a solution for this one. So 5 times 6 minus negative 2. That's 30. Minus a negative becomes a plus. So 32 equals, in this case, 32. So it works for this one. But in the end, it's not a solution because it didn't work for both of them. So that's what you want to be able to test. Test it for both of them, see whether, if it works for both, yes, it's a solution. If it works for one or neither of them, then it's not a solution. Now, the first thing we did in this section was solving by graphing. You're going to need to be able to show me the graph and then show where the lines intersect. So for y equals x plus 4, remember, this is in slope-intercept form. The number in front of the x is my slope, which is 1, or 1 over 1, and it's positive, so it's going over uphill. My y-intercept is the constant, which is a 4. That tells me where to start. Always on the y-axis. And now, since the slope is 1, go up 1 to the right 1, up 1 to the right, and then down and to the left. And if I graph that line, okay, so there's our first line. Second line is y equals negative 2x plus 1. My slope is negative 2 or negative 2 over 1, and it's going downhill. My y-intercept is 0, 1. Since it's going downhill, if I go up 2, I want to go to the left 1. And I do want to see where they hit. And since they did hit right there, that's a good sign. I'm going to connect here. I still want you to connect. You still need to show me that even if I don't want you to just do dots. Still connect. Now, our answer is right where they intersect, which is at the point negative 1, 3. Our solution is this ordered pair, negative 1, 3. And so that number or that ordered pair will work for both equations, and that's the only one that will work for both. All right, take a look at this fourth one here. Y equals x plus 6. Y equals negative 3x plus 6. All right, so for y equals x plus 6. Similar to the last one, the slope was 1 or 1 over 1 because there's no number in front of the x. The y-intercept is 0, 6. Slope is positive 1, so it has to be going uphill. So start at 6, and I go up 1 to the right, 1, and then I can go down and to the left, and then that'll be my equation, that'll be my line for y equals x plus 6. And then how about the other one? Y equals negative 3x plus 6. Slope is negative 3 over 1, which goes downhill. Y-intercept is again 0, 6. All right, well, what happens here? The y-intercept is 0, 6. Right there is where it hits. Boom. So I know that answer. You still have to graph it. You still have to graph it correctly. So you go up 1, 2, 3, and then to the left 1, and down 1, 2, 3, to the right 1, so that you can accurately graph it. All right, there goes that ordered pair. And we already know the answer. It's where they cross, which would be at 0, 6. So there's my solution, 0, 6. Okay, this is an assignment. Take the rest of the class, or if you're at home, finish this. Tell whether it's an ordered pair. You need to show the substitution in, and whether it's true. And now you can graph these on this paper because you already have those graphs there. So print it off, and just graph them on here. These here you might have to do on the back. Okay, is the same with 9 and 10. Okay, then we're going to take up a little bit more room. So see what you come up with for your answers here. Review, we are going to have a quiz tomorrow. If you are remote, I will post it, and you'll need to complete it and upload it. All right, hope everybody's doing good, and I will see you soon. Thank you.